Hello and welcome everyone. In today's session of geometric dimensioning and tolerancing, we are going to discuss one of the most important tolerances, which is profile of a line. And the second one, which we are discussing about, is a profile of a surface. Okay, so in this particular session, we are going to discuss about the two most important tolerances. Because they are considered to be the more versatile and powerful in terms of geometric tolerancing system. Okay, so in profile tolerance, we have, I have already told you, we have two types of tolerances: profile of a line, and one is the first one is called profile of a line, and the second one is called profile of a surface. Okay, so this is the symbol of a profile of a line. Okay, so whenever we are using in the first compartment of the feature control frame the symbol like this, that means we are using profile of a line. Okay, tolerance. Now, when a profile of a line tolerance is specified, the tolerance zone is a space within uniform two-dimensional boundary. Okay, so profile of a line, we have two-dimensional tolerance. Two-dimensional tolerance. Or we have two-dimensional boundary. Okay, so with the help of example, we will discuss this thing. So if I will go with the definition, so it is related to the datums. Yes, it is related to the datum. Okay, so we require datums in the feature control frame. In this, there is no MMC and LMC are applicable. Okay, so LMC or MMC modifier, material condition modifier, we don't use in this profile tolerance. Okay, so profile of a line describes a tolerance zone around any line in any feature. Okay, so profile of a line describes a tolerance zone. So whenever the line like this, you can see this line. So there is a line like this on any surface. It can be surface like this. It can be surface like any other surface. It can surface like this also. Okay, the part can any type. Just what we are showing is that the tolerance zone around any line in any feature. Okay, so it is a two-dimensional tolerance. So that's why we are talking about. So profile of a line is a two-dimensional tolerance zone, two-dimensional tolerance range that can be applied to any linear tolerance. Okay, so in this we can apply to any linear tolerance. If it is called out on a surface, let's say in this case this is a surface. Okay, so this surface we called out profile of a line. You can see this symbol over here, profile of a line. So we called out this profile of a line at one plane. Okay, so if we cut this part at one plane, the line which comes out, if we do a section view from the center, this line we will get the curved line, and that is the profile of a line. Okay, it should be within the tolerance zone, whichever tolerance we have provided. Here we have given 0.1 mm. Okay, so if it is called out on a surface, like radius on a part, profile of a line would specify how much that cross section could vary from a true curved radius. Okay, so profile of a line takes a cross section at any point along the surface and sets a tolerance zone on either side of the profile. Okay, so in this, what we are finding out, we are just checking that what is the right, this is the right surface, and this is the tolerance zone what we have. Okay, which is 0.1 mm. Okay, so this is very important that we should specify in a correct way. Okay, now we will understand when in as you see in this diagram. Okay, so in this diagram you can see particularly this phantom line. Okay, yeah, this is the point. Okay, so at any given cross section, what we are going to get in a plane, at this plane, let's say this is a single plane, and sorry, this is a straight line. Actually, you can think like this is a straight line, and we are cutting this part from this in a cross section, and we are checking at this plane. Okay, and this cross section we are checking that either it is properly curved or not. Okay, so we are going to have a profile of a line, that is profile of a line within the 2D boundary. Okay. So in 1997 standard of GD&T, ASME GD&T, what we give is we provide this phantom line. Okay, this phantom line we provide, unlike the other geometrical tolerances, when it comes to a profile of a line, okay, or profile of a surface, we have to specify which surface from where to where it is considered as a profile. Okay, so in this you can say that this symbol we are using C to D. Okay, what it is defining. So in this example, we have 2 points C to D. Okay. So in drawing also we have specified that this is C and this is D. Okay. So if if I will change the color, so you can see this, that here C point is given, here D point is given. So in this feature control frame in the bottom we have specified that from C to D. Okay. So this profile has a tolerance of 0.16, which is from the distance of 0 from C to D, between, okay, C between D. So this is the between symbol. Okay, I will tell you in detail about between, that why we use this between. So profile of a line within the 0.16 with reference to the datum A and datum B. Okay. So here datum A and B is already given between point C to D. So here in between symbol, between modifier. Okay. So there is a between modifier. Between modifier which we used uh, in the feature below the feature control frames. This is the major difference compared to the other geometrical tolerances, because in other geometrical tolerances we don't have to define the distance in between the points. We don't have to define the points that from C to D we have this tolerance zone. But in profile tolerance, whenever we are talking about the profile of a line or profile of a surface, we need to define these things. Okay. In the second major difference in this is here 0.6 mm geometrical tolerance. Okay, is already given, that can be defined in which the direction this allowed. Okay, so this is also very important, that this 0.16 in which direction it is allowed. So this 0.16, that direction is also very important. Okay, for example, here you can see in this example, here is a line which is put here. This tells us that profile of a line. This tells us that the profile of a line must be within the inside the actual part. In this side, this phantom line you can see. Okay, this phantom line is showing. This phantom line is showing the deviation which is allowed. Okay, and this is the actual part line. This is the actual line, and this is the phantom line which is showing the deviation. Deviation which is allowed is 0.16, the tolerance which we have given into the feature control frame. So now we will see some example of a in this. Okay, so if we move, how to measure the profile of a line of or a measurement. So basically profile of a line or and the measurement is done with the help of CMM. Okay, profile of a line is measured using a gauge that is reference to the true profile at the given specific cross section. Okay, so whatever 3D model we have created, with the help of that 3D created model, we can specify that this is the profile and this we need to check. Okay, because there are an infinite amount of 2D cross sections of any part, the number of locations of measurement points can be specified on the drawings. Okay, so we can specify onto the drawing that this position I want to check, this position I want to check, this position I want to check, this. So multiple positions we can check, that these are the positions which we have to check for the profile of a line. Okay, profile is usually measured using a CMM for more complex geometries. So whenever there are complex geometries, we use CMM. What is CMM? I have already told you this thing, that coordinate measuring machine. Coordinate measuring machine. With the help of coordinate measuring machine, we find out the exact coordinates of the profile. Okay. So with the help of probe, we check these points and collect point cloud data. In this, with the help of probe, we collect point cloud data, and this data we match up with the 3D CAD model. If that matchups, okay, the profile matchups, that means it is within the tolerance zone. Okay, or if it is varying within the tolerance zone, so in this we can check particularly. Okay, so this is the main way of measuring the profile of a line. Okay, now we are moving towards the profile of a surface. Okay, so in this is the symbol. This is the symbol we are using in the feature control frame, in the first compartment of the feature control frame, that this is the symbol of profile of a surface. Okay, it is related to the datum. It is an optional. Yes, it is related to the datum. Whenever we are using primary datum and the secondary datum in this, so it means that it is related. We cannot use maximum material condition or the least material condition in this case, or for datum, we cannot use maximum material boundary or the least material boundary. Okay, now, profile of a surface describes a three-dimensional tolerance zone. Okay, you can see that profile of a line is a two-dimensional, but profile of a surface, in this, the whole surface, you can see this whole surface over the part we are taking into a consideration. Okay, so in this profile of a surface, it is a three-dimensional tolerance zone around the surface, usually which is an advanced curve or shape. If it is called out on curved surfaces like a fillet or a welded part, the entire surface where the radius is has to fall within the tolerance zone. Profile control all the points along the surfaces within the tolerance zone range that directly mimics the designed profile. Okay, any point on the surface would not be able to vary inside or outside by more than the surface profile tolerance. Okay, so usually when surface profile is required, whenever surface profile is required, let's say we have surface profile, it is required over here, and we have mentioned over here 0.1 mm apart, mean it is a bilateral tolerance, which is 0.05 above inside the part and 0.05 mm outside the part. Okay, this is also very important thing. This we will discuss in a very detailed manner, that how we showcase into the feature control frame. Okay, so usually when the surface profile is required, there are no tolerance on the dimensions that describes the surface, that use the GD&T call out to give the acceptable range. Okay, so basically what does this means, that we provide the basic dimensions. Okay, so we provide in this case the basic dimensions. Now in this you can see, when it comes to a profile of a surface, also we have different ways of specifying. Okay, so in this case you can see that we can specify. So here in the previous case, if you see, this was the older in that case, it was the older practice in the 1994 standards. Okay, we were specifying the deviation with the phantom line. In this case, okay, this phantom line, as we showing this phantom line, this is as per the ASME by 14.5 1994 standard. Okay, so now it had been removed in 2009 standard. As per ASME 2009 standard, this phantom line concept has been removed. How it is removed? Okay, so you can see in this when in this that it was a very difficult to show this on a 3D model. Okay, so that phantom line showing is very difficult. Okay, so how it is removed? In 2009, we come out with the new modifier, which is called the unequally disposed or unilaterally disposed modifier. Okay, unilaterally disposed modifier. I will write it down over here. Unilaterally, it is already written over here, but unilaterally disposed modifier. Okay, so what does this mean, and how we get help, and how we have removed that phantom line? Okay, so what does this unilaterally disposed modifier means? This is the U symbol inside the feature control frame. So whenever we are using like this is the feature control frame. In this feature control frame, first we have defined the profile of a surface. Then we have defined the tolerance 0.3. Now we will show the symbol U and round circle. U under the circle is showing unilaterally disposed modifier. And if we are showing 0.3 mm again, means it is outside the part. Okay. Then we write it down the datums A with respect to datum A, with respect to datum B, with respect to datum C. Okay. So first of all, we will see profile of a surface with unilaterally outside. Okay. So whenever we written 0.3 mm after U, okay, the same tolerance if we are writing over here after U means that the profile unilaterally out, it is outside. Okay. So in this case, if I will make one diagram over here. Okay, so what does this means? That what we have tolerance, let's say the tolerance which we have is outside the part. Okay, if it is written 0.3 mm over here. Now we have two types of unilaterally disposed modifier. One is unilaterally outside and one is unilaterally inside. Okay, unilaterally inside modifier. So in depth we will see. So in this you can see that whenever we are giving unilaterally outside modifier, okay, let's say this is a part. This is a part. Okay, in this part we have given unilaterally outside. So tolerance zone, it is written over in this. You can see this is the feature control frame. It is written 0.5 mm U, 0.5 mm A, datum. So in this case, it is saying that this tolerance is outside 0.5 mm because 0.5 is written after it. Okay. So this is outside case. Similarly, for the internal feature, this is for the external feature. For internal feature also, in this case, same, it is written. Okay. So this is for the surface. This is for the surface. And this is for the hole. Okay. So in this also, it is written like this, that 0.5 U, sorry, 0.5 and datum A. What does this mean? It is also saying that it is outside the part. In this case, for external feature, the size is increasing. In this case, material is increasing. Material is increasing. Okay. In the whole, in the case of whole, it is, in this case also material is increasing, and it is small becomes the whole becomes smaller. Okay. So in this case, whole material is increasing, whole material is increasing, and it is become whole is become smaller. Whole is become smaller. Okay. So this is how we give the unilaterally outside for a profile of a surface. Now for the inner, for the, I will say, if we see unilaterally inside. Okay. So if we are providing, let's say if we are providing that in this case for the whole, you can see that 0.5 U 0. Okay. If we are using 0 means that it is outside. Oh, sorry, inside the material. Okay. So in this case, you can see that this is for the unilaterally inside example. Profile of a line unilaterally inside. Okay. So whenever we specify the profile of a surface 0.3, the total value will be 0.5. In this case will be inside the part. Okay. So in this, it is inside the part. So we are using 0.5 mm inside the part. Okay. So this is very, very important. So here we have an example of an external surface and the internal surface. Okay, applied unilaterally outside and unilaterally inside. Similarly, for the hole, we have understand. For the if we make zero over here, okay. So what does this means? That it is inside the part. The tolerance zone will be inside the part. Okay. So this is how we say we write it down into the second compartment, the unilaterally inside and unilaterally outside. Whenever we are making zero over here means it is inside the part. Okay. If we are with the help of examples, I will let you know that profile of a surface how we define it with the examples. Okay. So profile of a surface. Oh, sorry. In this case, there is a surface. How we measure the profile of a surface. Okay, so profile is usually measured using a cmm due to the complexity of some of the surfaces that are called out. The cmm would compare the 3D scan of the profile to the dimensions called out on the drawing to see if it was in specs. If a simple surface is called out, such as a radius or on a corner, a height gauge can be used to trace the part as long as the gauge can stay the same distance away from the surface as rotate around the surface. Okay. So multiple times point cloud data, multiple times we check on the surface. Okay. And this data, we rotate this part along that. So gauge must follow the true profile. So profile is usually measured with the help of CMM. Okay. So as the it is rotated, the part is rotated and come go and fro. So it is then the profile would be checked with the help of 3D CAD model. Okay. So we can compare with the help of 3D CAD model. In this case also we are calculating the point cloud data. With the help of that point cloud data, we create a profile and that profile should be matched with the 3D scan model or 3D CAD model. Okay, so that's how we can measure the profile of a surface. Okay, now in this you can see that profile of a surface in a equally in this. So here the phantom line is inside the material. Okay, so in this there are four examples. So there are four examples in this. One by one we will understand. Okay, so next we have the profile of surface, unequally disposed profile. Firstly, we will discuss about the bilateral tolerance. Okay, so what is bilateral tolerance? Whenever we have the 0.8 mm and we haven't shown any unilaterally inside or outside, so that means that the it is inside also and outside also. The tolerance zone 0.4 mm is inside and 0.4 mm is outside with reference to datum A. Okay, so in this first bilateral tolerance example, if we are showing 0.8 mm in the tolerance zone in the feature control frame, that means that 0.4 mm is outside and 0.4 mm is inside with reference to datum A. In the second example, it is clearly shown this is the 90, this practice is of as per the 1994 standard. Okay, so in that standard, this is how they show the phantom line. Okay, so this phantom line has been removed. This practice has been removed. Now we show like this. Okay, as per the 2009 standard, we use this 0.8 and U0 with reference to datum A. It means that it is inside the part. Okay, so whenever we are using 0 over here, that means it is the tolerance zone is inside. All 0.8 mm is inside the part. Okay, so this is called unilateral tolerance inside, and this is how we show into the feature control frame. Okay, so the datum with reference to the datum A. Now we will see unilaterally outside, unilateral tolerance outside. So previously it is shown with phantom line outside but this practice is already deleted. Okay, so we don't use this phantom line. We show like this into the feature control frame that 0.8 u unilaterally exposed outside 0.8 means that all the 0.8 of tolerance is outside the part. Okay, so in this case, it is showing that 0.8 of tolerance is outside the part. Now, in this bilateral tolerance unequal distribution, this is very, very important to understand that how we show the unequal distribution. Okay, so previously we show like this with the two phantom lines, but in this the practice has been deleted. In now what we how we show this is how this. Okay, so first we provide profile of a surface, then total tolerance what we have is 0.8 and unilaterally disposed 0.2 mm. 0.2 mm is outside. Okay, so here we can see that this 0.2 mm is outside the part, and 0.6 and rest 0.6 mm is inside the part. Okay, so what if we are writing over here 0.3 mm? Let's say if in one other feature control frame we write 0.8 total tolerance, unilaterally exposed surface 0.3 mm means here it will 0.3 will help, and here it will become 0.5 mm. Okay, with reference to datum A. So whatever dimension written after U, okay, it is for the outside. If it is written 0, means all 0.8 of tolerance is inside. If it is written 0.8 over here, means all the like this, means all the 0.8 of tolerance zone is outside the part. Outside the part. So now I hope you that you understand about the profile of a surfaces, that in bilateral tolerance how we show that like this. In bilateral tolerance it is shown like this. In unilateral tolerance inside case we show 0 because it is nothing outside, all inside. So all the 0.8 of tolerance is inside the part. In this case, for the outside the part, we show all the 0.8 after U 0.8 means 0.8 out of 0.8, 0.8 of tolerance is outside the part. In this unequal distribution, what we say is we show what is outside over here, and this outside will be minus with the total, will remaining will be inside. Okay, so if we minus 0.8 minus 0.2 means 0.6 so in this case you can see that 0.6 tolerance is for the inside and 0.2 is already shown for the outside. Okay, so I think this concept has been clear about the unilaterally disposed modifier. Okay, for the inside and outside and for unequal distribution. Now, now the most important part of that is profile of a surface. We use the symbol like all around. Okay, so in this case all around, we use this symbol like this. Okay, so this is a symbol what we use for the all around. So this is the symbol of all around, and what this means, what this all around means, that the surface of the part, in this case the surface of the part, profile of a surface. Okay, so which means this to say that the object line perimeter, so perimeter entire object considered as a single profile. Okay, so all the object, this all object is considered to be a single profile. Okay, the profile of a surface applied to the entire surface with reference to the datum A. With reference to datum A, we are providing this. So I will change the color to understand properly. So in this, so this is the interpretation of this. So all the actual surfaces most lie within the two 3D dimensional uniform boundary. So after manufacturing, okay. So after manufacturing, it will become like this. it should be within the tolerance zone of 0.6 mm. All around. Okay, so all the part surface should be within the tolerance zone. This should be within the tolerance zone. So all around the part should be within the tolerance zone. In 2009, one new modifier was added. In 2009 standard, one new modifier is added, which is all over. Okay. So what does this means about all over? In the previous example, you can see that we have used datum. Okay. So this is with reference to the datum. But in all over you will see that we are not using any datum over here. Why we are not using, I will let you know. So this is the symbol of all over. So whenever we are using the symbol like this, two circles, this means all over. This is the symbol of all over. Okay, so this means that all the surfaces of the part is considered for the profile tolerance. All the surfaces of the part is considered to be a profile tolerance. One question is, whenever we have all over, will not have any datum, because all the surfaces are bound to within the profile tolerance. Okay, so when all the surfaces are within the profile tolerance, we don't require datums. Okay, because datum surfaces are also be taken as the profile surfaces. So this is how the interpretation is actually done, that all the surfaces are 0.6 mm apart. Okay. In this case also 0.6 mm. So all over symbol means all over the part we have. So in this case, we don't have to use the datum references. Okay. Datums we don't require. Now in this next example, we have the between symbol. In the starting of the session, I have already told you that we used the between symbol because the profile of a surface, in this case, we provide in between if we have multiple let's say tolerances. Okay, let's say from datum a from point a to point v, we have 0.2 mm of tolerance. Okay, so in this position, this is for this position, this part profile, we have tolerance of 0.12 mm from but in this case, from b to c, from b to c, this profile of the part having tolerance of 0.1 mm. Okay. And from C to D, from this point to this point, I have tolerance of 0.05. Okay. So this is how we divide the tolerance zone within the same part. Okay. So we use this in between symbol. A symbol if we have a critical part, and we can give different tolerance value for different position of the part using between symbols. So this is the so I have already told you this example. So after manufacturing, the tolerance zone can be within the tolerance zone. Okay, so it should be like this. So transition between tolerance zone can be abrupt. So whenever we are having like this condition, okay, so there are other modifiers also overcome this problem, like form 2 modifier. In other session, I will discuss that modifier form 2. Okay. So this is all about the profile of a surface and profile of a line. Okay. So I think all the doubts, all the problems has been solved in this topic. If you have any doubt, you can write it down into the note section. We will definitely come up with the solution. Thank you. Thanks a lot.